You might think your car is already making all it can. You might be wrong. Today we're hitting 5 real cases where cars were leaving wheel horsepower on the table. Some were obvious, some were hiding behind sensors or bad assumptions. One car actually lost wheel horsepower after a tune, and yeah, that sounds bad until you see why it was the right move. By the end of this, you'll know if your car needs a custom tune. You'll know what to look for, what questions to ask, and what can go sideways if you skip logging. Quick context, these are street cars, not stripped down track monsters. Real setups that survive daily use and stay legal and emissions compliant. We're talking modern OBD2 ECUs you can flash. We use HP tuners, VF tuner, and proven profiles where available. Locked ECUs? Yeah, we touch those too. A lot of people think a stage 2 equals a custom tune, and that's wrong. We'll fix that. One small favor, if you like honest work, hit subscribe. We do real builds, explain the real price, and call out real risks. No hype, no snake oil, no magic beans. And now the challenge? Some cars look tuned, but they still run like garbage, and we're gonna show you why. All right, we'll start with this. The ECU controls fuel, timing, torque limits, cam timing, boost targets, and throttle response, plus a bunch of other stuff. It reads sensors and adapts. And when you flash a tune, you change those factory values, and that's the basic act. What the industry professionals call a box tune or can tunes are files made to work across many different cars. It's a blanket. It assumes common hardware. It can give easy gains for basic bolt-ons. These are the ones you buy when you don't have to put in build information and come out with a set price, which is part of its weakness. It cannot know your exact parts, your exact fuel, or the quirks of your engine. That's why custom tuning exists. Custom tuning means we read your exact ECU file, we log your car on the road or on a dyno, and we edit the fuel tables, ignition timing, torque management, cam maps, MAF, or speed density calibration, boost control if present. Then we test and log again. We repeat until stable and safe. Custom tuning is technical work. It's data work, it's not guessing. You need air-fuel ratio sensors, knock monitoring, fuel pressure readings, and good dyno data. You need a tuner who knows how to read that data and adjust for optimum performance. A note on locked ECUs, and you guys might know about this, but some cars have sealed bootloaders like the S650 Mustang, which was locked until recently, and you probably all know about the BMW DMEs that have to be unlocked from a third party like Femto, and of course that adds time. If your car falls into that category, you gotta expect extra steps before tuning. Bottom line, a custom tune tailors the ECU to your car, not a car like yours. If you want predictable performance and safety across a full range, custom is your only path, but it's gonna cost you. People love throwing around stage 1, stage 2, stage 3 like they're levels in a video game, but here's the thing. Those terms don't have universal definitions. They're just a quick way to describe roughly how far down the rabbit hole someone's gone. Now, as a professional, I get the value. It gives people shorthand, but let's be real. If you're the guy online correcting everyone's usage of stage, thinking you're educating the world, you're not. You're a dork, so relax. It's general terminology so people can talk about cars without writing a dissertation. And on the flip side, if you're out here calling your stage 2 G37 or your stage 3 2.0 Golf built, slow down, champ. You're not the hero you think you are. Both sides of that coin need to chill, and here's what the stages generally mean in the real world. Stage 1 is mild stuff. Intake, tune, maybe an exhaust. The fuel system is almost always stock when talking about stage 1. The car is still basically stock, just breathing better. Stage 2 starts adding in the stress. Downpipes, high flow cats, intercoolers, pulley changes, that sort of thing. The ECU needs to know what's up or it'll throw a tantrum. Stage 3 means you've gone all in. Big turbos, injectors, maybe cams or a built motor. And at that point, if you're still running a can tune, you deserve whatever chaos happens. 2 points matter here. First, stage labels do not replace inspection. Second, a custom tune can be applied to any stage really. A stage 1 car can get a custom tune for drivability. A stage 3 car can have a custom control just to stay safe. These labels help people to get a quick idea of where the build is at, but they're not gospel. Every shop defines them a little differently, and what matters isn't what stage you call it, it's how well the car actually runs when you're done. Now you guys should remember this one, 40 wheel from headers and exhaust on an E85. That looked like the end of the story, but here's the thing. E85 is not a single tune button. Fuel chemistry changes behavior, sensors change behavior. The ECU has to guess when it lacks direct ethanol feedback. That guess costs power and safety. We found that guess on this GT350, and what happened next matters when you run E85 or plan to switch fuels. Now, over 500,000 of you guys saw us extract 40 horsepower with stepped headers, a Formula Z Z-pipe, our megaphoned exhaust on a GT350 with an E85 tune. But what if I told you there was still 25 horsepower left in a custom tune? Anytime we have a big tuning project where we're trying to dial something in, we usually do most of the logging on the street and any sort of slight adjustments before we actually get it on the dyno, so we're not wasting time with drivability concerns. This car's ready to go. We've got it strapped down, and basically we're gonna see what we can push on E85 and this beautiful exhaust system that we've done. Now, tuning the GT350 is a little different than tuning other cars because there is no dedicated flex fuel sensor. So that means all of the calibrations and everything that you're doing inside of it, there's no direct feedback from a sensor to tell it to modify. So what it's doing is actually checking multiple sensors through a huge range of running to verify that E85 is in the car. And then you've got to go in and modify all of those values and all of those tables in order to extract more power from the fuel. Now here's what we actually edit when the car lacks flex fuel sensor. Volumetric efficiency tables, injector dead time, pulse width, ethanol correction factors, transition maps, fuel rail pressure, timing retards. Everything must be adjusted carefully. It takes patient street logging and steady dyno runs, and you need a tuner who knows the platform. Which is why my only choice for the job is my good buddy Bader from Norris Motorsports, located in Kuwait, who not only has the skill base, but the patience to take the time to go through all of this, which is modifying not just an E85 file on this car, but all of the modifications that we've done, the long tubes, the Z-pipe, and the intake, in order to get the safest, most repeatable power for these mods. Truth be told, custom tuning is a black box that you don't know what you're gonna get until you get in there and start messing around. But numbers like these really prove that a custom tune is worth it. Over 25 wheel horsepower to a car with already a box E85 tune proves that there's more left in there if you take your time and go through it. And having guys like Bader at Norris Motorsports in your back pocket to help you do something like that is invaluable to us and the customer. Now what this all proves for you is a box E85 map can be a strong start, but it's rarely a finish. If you run E85 or swap hardware, often expect follow-up tuning. But here's some quick checks you could run now. Long-term fuel trims at cruise. If trims swing beyond plus or minus 10%, something's off. Watch AFR during steady wide open throttle pulls. If AFRs wander more than 0.3 commanded, check fuel pressure and injector scaling. Log timing, actual versus requested. If timing's being yanked under load, the file is asking for more than the engine can safely deliver. Best repeatability fix, you need a flex fuel sensor. Best result, time with the Pro Tuner. And on that GT350, we found smoother power and about 25 wheel over the box file. Now what happens when an engine croaks, but instead of just replacing it, you decide more displacement is the answer? And while you're at it, you stroke it too. The problem? A stock file. The new engine breathed with bigger lungs, but the ECU was still sipping through a straw. All right, what we've got here is a 2006 BMW M5 with the S85 V10 engine, but this isn't your normal S85. What this car has is the stroker kit that pumps this thing out to 5.7 liters V10. Now this customer came in because they were having some issues finding a reliable tuner to dial this thing in, and the results reflect that. Changing displacement isn't just adding air and hoping for the best. More volume changes how the engine breathes and reacts. Cam timing, ignition events, torque limits, throttle and mass airflow mapping, all of it has no idea what to do with all this extra space. We've got two graphs representative of what's going on. 380 horsepower on my dyno is typically what these cars make from the factory before we touch anything. So that's an OEM run. Now obviously I don't have an OEM run from this car with the 5.7, but what I do have is what it just dynoed at, and that's 413 horsepower. AFR logging told the story. Rich in some spots, lean in others, timing pulled under load. Plugs confirmed that this was all the ECU giving its best guess. So we're about to start trying to see if we can make any more power over that 413 or if this thing's pretty well tapped out, but already I see that this air-fuel ratio is looking pretty rich, and if we can bump that up, there might be some more power to be had. We did what BMW would have done with this upgrade. Tuned the fueling maps for the new displacement, adjusted cam tables to match the volumetric efficiency, tightened the torque management so the trans wouldn't freak out, and verified cooling margins and the EGTs stayed safe. The result, the torque curve filled in, throttle response sharpened, and the V10 was finally alive from idle to redline. Some of you might remember this case from before, but it's worth revisiting. We worked on an Audi TT with a stage 2 tune and aftermarket intake manifold. Dyno numbers look solid, expected even, but the ECU was pulling timing under load, saving the engine from itself. That off-the-shelf file was aggressive, yanking spark to avoid detonation. We started the custom tune and, at first glance, the peak numbers dropped. Charts made it look like we lost power, but the knock data told the real story. Before, 6 degrees of timing were pulled in the critical torque band. The engine was flirting with detonation. And after our tune, timing stayed steady. Knock counts disappeared. Losing wheel horsepower in one spot was the right call. The car became safer, more predictable, and still gained usable performance. This is where the more peak power equals a better tune myth dies. If your ECU yanks timing under load, a custom tune can reduce the numbers in one area to protect the engine while improving overall performance and behavior. Always pick a stable engine over a flashy dyno chart. For the full story, or if you missed it, check out our complete TT tuning video. Logs, dyno runs, and patience clearly beat chasing peak numbers every time. So a Land Cruiser rolls in with a Harrop-supercharger and still the factory ECU file. Stock tune, 9 PSI, 0 calibration. And apparently that's fine. Harrop's install guide says low boost doesn't need a tune. From a manufacturer's view, that keeps the warranty and emissions folks happy, and I get it. But 9 pounds of boost with stock timing and fueling? My inner voice screamed, nope. Turns out it was safe in a pig-rich and lazy timing way. Nothing detonating, but the ECU was acting as the world's most cautious babysitter. Baseline dyno, way down from expected. Timing yanked, fuel dumped excessively, the ECU confused by airflow zones the stock map never anticipated, and heat soak made fuel control sloppy. We fixed it. Custom calibration, cleaned airflow models, corrected fuel targets, balanced ejector duty, and brought the timing up, safe, but not afraid of itself. Fuel pressure was stable, power was up, drivability was way better, but still street legal. Now I will say this, tuning Toyota products isn't for the faint of heart. VF Tuner, if you're watching this, you already know you make life harder than it needs to be. The support is rough, access is limited, and the process is, let's call it character building. So I get why a shop would slap on the blower and say, no tune needed. If it doesn't blow up, hey, mission accomplished. But let's be real, Running a supercharger with no calibration is like playing darts blindfolded. You might hit the board, but you're probably hitting the wall at least once. Now this Mustang was already sitting at over 700 wheel horsepower on our dyno. The owner had recently swapped out the intercooler and wanted to upgrade the intercooler piping, which we did, but that changed the MAF behavior. The previous tune was good, but with the new piping, the ECU was freaking out over the new airflow. Now what we got here is what some might consider to be a stage 3 tune. Technically though, it is a full custom build in need of a tune. And there's some gray zone in there when you're talking about stage 1, 2, and 3. Because typically 3 is more or less modifications to something that's set. You know, a supercharger kit, you know, a build kit, a turbo install, something along those lines that needs dialing in. Now this 2017 Mustang GT did not come with a supercharger. Everything's been done in order to build a very powerful vehicle. The Coyote motor's been built with internals to handle the boost level that he's throwing at this thing. Fuel system is unique to the vehicle, the intercooler, and what we did this last run. You guys may remember this car from 2 exhaust videos we did previously where we did a full system on this 3.5 inch. What we did recently was redo the intercooler charge piping in a way that fit more easily underneath his hood for his build. That actually included redoing the mass airflow on the cold side charge piping here, meaning we had to step down the sizing, and because of that, this ratio of where it's seeing the air now has to be completely redone by the tuner in order to work again. Now, he didn't really like the hodgepodge of piping that he had. He was looking to get something that had less points of connection for failure, so that way when the thing did boost, it was less likely to push off a intercooler hose clamp or something along those lines. So we fabricated this pipe. But what we need to do now is go over his unique build, his file, and send the rendition so that way we can dial in this mass airflow meter for the new charge piping setup. So in reality, it should just be some MAF recalibration levels, but this is where custom tuning comes into play, where we need to dial it in for what he has already set up, the tune that he already had working previously, and it needs to be adjusted now in order to make this work. We helped clean it up. We corrected the MAF scaling. We made sure the tuned airflow tables for the new piping diameter were good, adjusted the transient fuel tables, and made sure the torque tables were in line so nothing would surprise him. It wasn't about making more power. The car already had plenty. What this gave the owner was peace of mind. Pipes were popping off, the ECU wasn't guessing, and the engine base stayed clean and predictable. Sometimes tuning isn't about peak numbers, it's about a simpler, smarter setup that works without drama. All right, so you've seen what we've done with these cars, from the GT350 wrestling with E85 chemistry to a stroked M5 V10 trying to sip through a straw, the Land Cruiser with 9 pounds of boost and no clue what to do with it, and this 700 wheel horsepower Mustang whose MAF piping was throwing the tune off. Each one had different mods and different headaches, but the principles are still the same. So how does tuning actually work? The short answer is data, caffeine, and the patience of a saint. But before you even touch the ECU, we log everything. RPM, manifold pressure, MAF, fuel trims, AFR, lambda, timing, knock counts, fuel pressure, if direct injected, throttle position, and if boosted, wastegate duty. And if you want the nerd level walkthrough, check out my video, Tuning Your Car. Watch this to learn how to data log with confidence. From there, the workflow is consistent across every car we've covered. Mechanical inspection, plugs, filters, fuel system, boost plumbing, and then baseline logs and dyno pulls with the current file. Identify problem zones, fuel spark airflow, street logging for part throttle and real world behavior, dyno runs for verification and iterative runs, and just expect multiple revisions. That Audi TT took over a dozen files before it behaved. The GT350, same story. E85 required patient calibration. Now, tuning is never one and done, but what do you look for in your car if you're thinking about a custom tune? Let's start with fuel trims. If you're seeing them swing plus or minus 10% at cruise, and we did see that on the GT350 with the E85, you might need a tune. If you see AFR wandering more than 0.5 lambda under load, like we saw on the M5 and the Land Cruiser, you might need a tune. Timing, if it's dropping multiple degrees under load, like the TT, the M5, and even the GT350 when it was in its aggressive part of the table, you might need a code. This is probably the biggest one, misfires after mods. Now, that's pretty common with displacement changes or big airflow work like the intake manifold, but spark plug deposits that don't match the expected burn, like the M5, well, you probably need a tune. Fuel pressure, if you see it drop during pulls, and that was big on the GT350, you might need a tune. Boost not matching commanded targets like on the Audi TT, you probably need a custom tune. Throttle dead spots or hesitation after mods in part throttle or even full throttle areas. Now, we really felt this on the M5 and the Mustang, but very noticeable on the TT. Now, these are great examples, but if you have any of these, a proper custom tune can usually fix the issue. And sometimes it exposes a hardware problem that you didn't know existed. That's the hidden value of diagnostic. Good tuning isn't about one big peak number on the dyno. It's consistent, safe, usable power. Loud, easy, smart. What I'm really getting at is it's going to take time and patience. You're going to have to log and know what you're looking at. Just like we showed on the GT350, the M5, and the Land Cruiser, they're all different cars, different mods, but the same rules. I keep telling you guys it's going to cost you, so let's talk money and time. Now, tuning costs do vary, and you pay for expertise and time. And at FMU, we charge a flat rate of $500 for the dyno, and that gets you dyno access and baseline logging. After that, the tune work is billed hourly. Our tuners range from $400 to $1,000 per hour, depending on complexity. You're also going to pay for licenses or devices to pull and write files if it's required. And for standard custom tunes, I'd say you got to expect to spend at least $1,400. But for complex development that must pass emissions and requires unlock steps, costs can climb to $4,500 or more. Why this range? Because some cars take an hour and others take dozens. Locked ECUs add time, fuel system upgrades add time, street logging takes time, and a good tune needs proper verification. Cheap, quick tunes that promise big gains often skip all this verification, and that costs you later. Reflecting, we turned raw parts into usable power. We tuned fuel, ignition, MAF scaling, boost targets, smooth torque curves, balanced power, but most importantly, safety. Now, the trade-offs on that Audi TT, we gave back low-end wheel horsepower to remove some timing pull, and that felt like a loss on a chart, but it was a gain for the engine. The other cars, all extra wheel horsepower without the cost of the engine life. And the outcome? Well, that depends on your starting point. The old way with tuning culture was bolt on and hope, but the new way, data and measured change. Push cars hard, sure, but do it with the right data and mapping. You got to balance price, drivability, performance, safety, and reliability. Now, buy parts to impress, that's fine, but spend on calibration. Daily confidence with parts that actually work. Both of these are valid, but we prefer reliability and usable performance. Cars are tools, they're toys, they're statements. We tune so they work as all three. But our job is to understand these machines and help you use them without surprises. The best gains come from knowing what to fix, not just what to add. Now, I want to hear you comment below. What would you change about your car? Maybe brag about mods or spot hidden problems. Tell us the symptoms and we'll try to help. One last thing, cheapest option, box tune and hope. The right option, diagnostics and proper map. And the smartest gamble, spend on knowledge. Keep receipts, stay loud, stay curious, and we'll catch you on the next pull.